Hello, everyone. We're going to wait a couple more minutes for everyone to get here around 1:05. But yeah, I'm happy to have you all guys here. By the way, can you guys hear me? To answer your question, there will be software. I mean, you can download the Arduino Ide. However, since we cannot really provide you guys with the hardware for this workshop, it's going to be more like an interactive building this robot workshop. However, as I go through it, I will tell you guys like why I chose the parts that I chose, how to program everything together so it works. And even though you guys won't be able to actually build a robot by the end of this workshop, I'm pretty sure you'll feel confident enough to do so if you end up getting the hardware. I mean, I'm sure if you guys plan to build a robot project for this hackathon, you already have the hardware, so like this workshop is to help you out. But if you're just interested in how robotics works in general, definitely this is going to be a good workshop. But yeah, I'm just going to wait a couple more minutes to get started. About 1:05. I'm super happy to see so many people though. Welcome, everyone. So yeah, we're starting in 4 more minutes. Thank you. Thank you. Definitely, it's going to be a cool one. All right. I mean, we still have people coming in, so I'm just going to wait a little bit longer. But yeah, how are you guys feeling about the hackathon though? Are all of you making projects? That's great. That's what we want. I'm going to give a little sneak peek of the robot we're going to be building. I have my webcam aiming at it, but it's basically going to be a robot that not only is able to move and stuff, but basically has a line follower aspect. So it's going to be able to run through the line, and if it's getting outside the line, it's going to be able to detect that and correct itself back in. So if you have, and actually let me pull it out here. 1 second. But yeah, this is just an example. It's going to make more sense once I show you guys. But yeah, I'm just going to, this was just a little sneak peek. We're going to start at 105. I actually have it here in a video somewhere. I'll find it. Okay. Wally, honestly, it's not going to be as complex as Wally, but it's going to be up there. No, I'm joking, but by checking out this workshop, you guys will be able, if you have the hardware with you, to get started and build whatever robot you guys have in mind. I'm happy to see 30 of you guys. That's amazing. Yeah, just 2 more minutes. Today. Select folder. Yeah, we don't have any hardware required because this workshop is going to be more of a walkthrough on how to build a robot and how to choose the parts that you need, right? And then how to program it. It's going to be very general since we cannot provide you guys the hardware because we're remote, but I still wanted to be able to a very interactive way, and you guys can ask any questions throughout the way. I have pictures detailing every step. And this is just an example of it working at the end. It just follows a line around. I know hopping is very laggy, so I hope it's understandable. But yeah, it's around 105, so I'm gonna get started already. Welcome everyone to our intro to Robotics Workshop. Throughout this workshop, we're gonna pretty much build a robot from scratch. And as we're building it, I will teach you guys all the basics and everything that you need to know to create your own robotics project after this. As we build it as well, I will teach you the concepts of not only how to control the motors, how do you use an Arduino, how to interact with the sensors, for example, in this case, to detect the line, and how to make the robot react to these changes in the sensors in the way that you want. So yeah, first I'm gonna test the Arduino, right? And no, my bad. First I'm just gonna test the Arduino. And for this, if you have your own Arduino, you can run the Arduino Ide. And don't worry guys, I'm gonna make this bigger so you all can read. I hope that's a little more legible. So this is where you're gonna see if you try to program your own Arduino, right? And here I'm also gonna share my webcam so you guys can see. Oh my God. Well, for now I'm just gonna share my webcam. So here we have our Arduino, right? I connected it to the computer through the main port here. It's connected to my USB. As you can see, the Arduino is already lighting up. That means that it's getting power. Can I run it directly from terminal without needing the Arduino IDE? Actually, you can't. You will need some sort of either plugin or library, because what the Arduino Ide does is not only it provides you with a very simple tool to program, but it also provides you with the tools to actually target your code to run in your board. So if I have an Arduino Uno, I can tell it, yeah, run an Arduino Uno. But if I had any other type of Arduino, I could do so as well here. And that's what you don't get directly from the terminal. You could technically program it from the terminal, but you would need to go through a lot more steps. And this is just the easy way. And then you also see the port. So something that you have to check before programming anything on your Arduino, you have to check that you have the right port selected and the port as well selected. How do you check that? In the Tools tab up here. I'm gonna make the screen a little bigger. So you have two main functions. I mean, I guess you guys can see it, right? What do these functions do? Well, the setup function runs once in the beginning of the program. Usually you use the setup to declare any variables that you have, or you can declare them as well outside here. Doesn't really matter. But there's certain things that you're gonna wanna do that only happen in the setup. And one of them is one that we're gonna use right now, which is serial.begin 9600. Now you may ask yourself, why am I using this command? Well, if you have the Arduino and you want to be able to print values from the Arduino to your computer, I imagine in a case where you were debugging your software, maybe something's not working, you want to be able to print. Well, you have to remember that the Arduino is a separate device. So you're not really able to print to the console directly like you would with any other program. Instead, you have to go through the serial interface, which is happening through the USB cable, and then you're able to print it here. All the workshops will be recorded? Yeah, they will be posted in the UP FIO channel. So after I begin my serial communication, then I can do this here. Serial.printf, println, my bad, hello world. And what you guys are gonna see is, well, if I save it and I run this, it takes a little while to compile. It's like that sometimes. I forgot to put a semicolon at the end. Yep. Now you can go here on the top right, you're gonna see this little thing called serial monitor. If you click it, then you have access to the serial console. And that's how you see all the data that is being printed from the Arduino. So while you're debugging your program, this is great, right? Because you're able to actually see it in your console. So yeah, so our Arduino is working, right? That's good. I'm gonna go ahead and also share. I think you guys can select what screen you guys are looking at. So that's gonna be helpful because I'm using my webcam to show the robot. But yeah, let's keep going, right? So since our Arduino works, I wanna get my motors working. I feel like whatever robot you're building, the movement of it is gonna be very important. And that's the first step usually. So before I get into how to get our motors to work, I want to explain to you guys what are some common types of motors that are used in robotics. And the first one is the brushed DC motor. It's the one that we're using in this robot, right? What are the advantages? Well, it's low cost, it's easy to control and drive, and it has a very high power and torque for the size. The disadvantages is that it wears down because it has physical brushes, and I'm going to show you guys here. The reason why it's called a brushed motor is because it has two brushes on the sides, which are constantly giving the motor voltage and ground. So as it rotates, you're giving a voltage and ground with the brushes in different sides of the coil. As you can imagine, having a physical brush rotating at, I don't know, 1,000 RPM for an unlimited amount of time is going to wear down eventually. Another very common type is stepper motors. These are used mostly in 3D printers, but they are very high precision motors. And yeah, I mean, if you have any use case that needs very high precision, like a 3D printer or a plotter, you will use this kind of motors. These are a lot more complicated to run. A fun fact about brushed motors is that you can run them by connecting both ends of the motors directly to a battery, and it's going to rotate. A stepper motor is a lot more complicated. You need to send a specific amount of signals, and to do that, you will use a specialized board. But we're not going to worry much about this because we're not using a stepper motor. Finally, there's brushless motors. They're used proficiently in drones and also robot dogs. They're very fast. They have very efficiency, and they don't have any sort of contact. So they also last a long time. The only disadvantage is that they're very expensive, and they're also very expensive to run. So yeah, enough talk about motors, right? How do we drive the motor that we have here? I told you guys that you could literally run a DC motor by connecting it to a battery. You know, the positive end of the battery to one of the wires in the motor, the negative to the other. But this comes with a couple problems. What if I want my motor to rotate the other direction? Something you could do is flip the battery, right? And the motor will rotate the other way. But, you know, in a real use case, you're not going to be able to flip the battery on the fly to actually make your go backwards instead of forwards, right? And what happens if you want to control the speed of the motor? You're also out of luck because motors work like the speed of the DC motor is directly proportional to the voltage of the battery. So the speed of your motor is going to change as your battery is draining. And that's all there is to it. You have no control over that. This is where we bring a motor driver. This right here is a very popular motor driver for DC motors. A lot of robots out there use it if you have DC motors. If you have made your own robots before with DC motors, you've probably seen this before. But it's what is called an H-bridge. And right here on the right, there's like a simplification of what an H-bridge does. You see 4 gates, right? 1, 2, 3, 4. And there's a motor in the middle. Imagine what happens if I close gate 1 and 4. Well, one side of my motor is going to be connected to voltage, and the other side is going to be connected to ground. This is going to make my motor rotate one way. But if I close instead gates 2 and 3, the motor is going to rotate the other way. So you're able to control the direction of the motor on the fly without having to physically swipe the cables or the battery. So this is why this is so great. And 1, 2, 3, 4, all these 4 things are controlled with these 4 pins here. You guys can see input 1, input 2, input 3, and input 4. So yeah, that's pretty cool, right? So input 1 and input 2 are going to control motor A. Input 3 and input 4 are going to control motor B. Motor A is plugged here. Motor B is plugged here. So how do I interact with these pins here? Well, if I set pin 1 to be high, aka 5 volts, and then pin 2 to be 0, aka 0 volts, or low, then the motor A is going to rotate one way. But if I do it, if I flip it, instead I make input 1 become 0 and input 2 become 1, then the motor goes the other way. That's the main way on how this motor driver works. And since you have 2 motors, you're able to do this with pin 3 and pin here. Now, I know that was a lot of information, but that's all you basically need to know. Except there's one extra detail. There's going to be 2 extra pins on the sides. They're called Enable A and Enable B. These pins control the speed of the motor. So if I set Enable A to be 0, the motor is not going to turn. But if I set Enable A to be 5 volts or high, then the motor is going to turn at full speed. And any value in between, the motor is going to turn at that speed. For example, if I put Enable A to become like half of 5 volts, then the motor is going to go at half the speed. I hope that makes sense. That's the main gist of how you control this. And it's all going to make a lot more sense once we do it in the Arduino Ide. But yeah, another thing, this is the last thing we have to deal with this controller, is you have to power the motor somehow, right? So you're going to have 2 pins here. VS is going to be main voltage, and then ground is ground. Usually, you want to power your motors directly from the main battery. Why is that, right? You may ask yourself. Well, the Arduino always runs at 5 volts. If you give more than 5 volts to the Arduino, it's going to burn and not work anymore. However, motors usually like more than 5 volts. The motors that I have here can run all the way up to 12 volts. And I mean, if I give them 5 volts, they're going to be pretty slow because, as I told you guys, the motor speed goes linearly with the voltage. So what we're going to do for our project is we're going to connect the battery directly to the motor driver. Our battery is going to give the full voltage to our motors. And then we're actually going to take advantage of the motor driver because it outputs a 5 volt pin here. And we're going to power our Arduino with this 5 volt output. So we're going to be able to, our whole robot is going to be able to power the motors, and then the Arduino is going to be able to be powered, all thanks to this board here. So even though it's just a simple board, it's going to do most of the lifting for managing our motors and also powering our Arduino. Okay, I know this was a lot, but now we get to the fun part. We get to actually program it, right? So let's go. If you guys can, turn to the, well, actually, no, 1 second. Before I actually get to program it, let me show you guys a little sneak peek of like what is built. As you guys can see, we have a battery here. And this is just 4 AA batteries. The positive side of the battery is going to a switch. So I'm able to turn on and off the robot in real time. If I feel like I want to, sometimes you just don't want it running away from you as you're programming it. So having a quick switch, a quick way to turn it off is very useful. And then the ground is going over here. Let me actually use the laser pointer. So yeah, we have 5 volts coming to the switch and then going to here, and then the ground here, all the way here. Another thing is we have 2 motors, and both of those motors have the cables coming out of them as well. There's 2 cables per motor. As we remember, we plug the motor cables to these sides here and here, and then we power the main power here. Okay, so let's do it. Let's do that, right? Let me show you guys. I mean, if you guys see my camera right now, you're gonna be able to see that I already have the battery set up. And here, the camera is flipped, but I guess you guys can see it. This right here, this cable that I have my finger on, This is the main voltage coming from the battery. And these two cables right here are connected to ground. These two are connected to ground. Now you may be asking yourself, why are you connecting two cables to ground? I mean, you just told me that I just needed to connect one cable to ground, the battery, right? Well, that's not completely true. If you want to communicate between the Arduino and this board, and I mean, we will communicate with this board, right? Because we have these 4 input pins, and those are essential, so we can tell the motor driver which direction we're rotating. If we want to communicate with any external modules, any sensors or anything, you have to have a reference ground. And I am having that reference ground here by basically connecting the ground from the motor driver to the ground pin in the Arduino. I hope that makes sense, guys. Yeah. Ground from the motor driver to the ground pin in the Arduino. I mean, that's the ground pin, and it's connected to the motor driver. So, yeah. I mean, that's it for now with the camera. That's the first step. Now, the second step is we have these 4, actually 6 pins that we want to define, right? Input 1, input 2, input 3, input 4, and then the 2 enable pins. So what I'm going to do for that is, well, let me find it. Okay, here. It's a little tricky to do it with a webcam. I hope it's doable. So what I'm going to do is I'm actually going to connect a bunch of jumper wires. I'm going to connect a bunch of jumper wires to that place, and then those jumper wires are going to be connected to some of the digital pins in our Arduino. And there's a better description of that happening here, there. I'm basically connecting on the left 6 jumper wires to the motor driver, and those jumper wires are being connected to the Arduino. So far, so good, right? So yeah, I'm gonna do that quickly here in the robot, and then we're gonna be able to actually get started programming our motor. Perfect. And then here, just 1 second, guys. Yeah, this is the trickiest part about doing projects with Arduino. It becomes a mess really quickly. So far, what we did over here is, actually I did this backwards compared to the picture, so let me do it again. Just 1 second, guys. But yeah, this is kind of the process you will be going through if you wanted to have a robot that moves around and has motors. So yeah, just like the picture, I was able to do this as well here. Now, our enable A is connected to the pin number 10. Enable A, which is the red cable here in the presentation, is connected to pin number 10. Same applies to input 1. The brown one is connected to 9. Input 2 is connected to 8. Input 3 is connected to 7. Input 4 is connected to 6. And enable B is connected to 5. Since we have all that working, let's just go to the IDE and actually do it. So in my Arduino IDE, I'm going to be able to define the pins, right? So I'm going to create a bunch of variables. For example, the first one is going to be called enable A. And this is going to be pin number 10, right? Input 1, going to be 9. Input 2, going to be 8. Input 3, 7, 4, 26, and finally input. Oh my god, enable B. Enable B. It's gonna be 5. And I mean, if you remember, this first 3 are to control the motor A, and these other 3 are to control motor B. Enable A is to set the speed of motor A, and then input 1 and input 2 set the direction. But then enable B set the speed of motor B, and then input 3 and input 4 set the speed of motor 3, set the direction of motor B. Now, if we go back to here, well, I'm gonna actually use another of my workshops as a reference. Just 1 second. So it's Arduino. Now, this was a workshop we had an hour ago. If we see at Arduino, you guys are gonna see that we have a bunch of digital pins and a bunch of analog pins. Now, the property that the digital pins have is that you can use digital pins to read or write digital signals. What are digital signals? Well, they are zeros and ones, just like it shows here. High or low, 0, 1, or 0 volts, 5 volts, whatever you want to call it. That's what digital does, right? And as you guys remember, to control these pins, input 1, 2, 3, 4, we do it with highs and lows. So before you use a digital pin for an output, you have to tell the Arduino what you want to use it for. And for that, you have the function called pin mode, and then you're going to give it enable A output. And it's going to be very repetitive. Input 1 output. You have to basically do this for every pin that you want to use in the Arduino digital pin. 2, 3, 4, and then finally enable B output as well. And yeah, we define them. Now I don't want to say hello world anymore. What I want to do is actually make my motor move. So as you guys remember, the enable pins are to set the speed. So if I grab, let me just put here set speed. If you do digital write, this is a function that allows you to actually set a digital pin to be either high or low, right? So I'm gonna set my speed pins, which is enable A to high. This is gonna make the motor A to be a full speed, and digital write enable B to high as well. Now I want to set the direction of the motors. Set direction of motor A. Digital write input 1 to high, then digital write input 1 to low. As you guys remember, by setting, oh, this was a mistake there. By setting 1 to high and the other to low, we go one direction. If we wanted to move the other direction, you will flip this. You will make this low and this high, if that makes sense. But for now, I just want to have it this way, just to test it. And that's all I'm going to do for now. I just want to test motor A. Let me see if it works, right? So I'm actually going to run the code. Here, I forgot to put a comma. Let's compile it again. Perfect. Oh, as you guys saw, my robot started running away. So if you guys can see, my right tire is actually moving. So we can know now that our motor A is the right tire. Now I have this this switch on the bottom just for this scenario. Now I turn it off. I genuinely thought it was off. I'm so sorry for that, guys. But yeah, that's how you move one of the motors. Isn't that kind of cool? Now, I actually want to be able to move both of them at the same time. So I'm going to also set the direction for motor B. Set direction of motor B. Then you would say digital right. I'm just going to copy this. But we will use input 3 and input 4. And if I compile this, we should be able to see. Okay, let me turn it on. Ooh, that's interesting. So only one of our motors is working, not both of them. Let's see why. Is everything connected correctly? I think so. Yeah. Okay. Okay, let me just debug this real quick. I probably messed up something in the code. So let me just see here 1 second. Digital speed, enable B, spin number 5, enable A, spin number, okay, spin number 5, high, high. I'm just gonna compile it again and see. Yeah, man. Oh, there we go. Okay, so my cable was actually pulling onto the motor. Both of them are working, as you can see. Okay, but still, this is a very, I would say this is a very rudimentary way of programming a move function. I mean, at the end, I want to be able to actually do something quicker. Like instead of all of this, I want to be able to just write, yeah, I want to move my motor A to a certain speed. Motor A to a certain speed, right? The speed is going to go from 0 to 255. So a speed of 255. Or I want to be able to say move motor A to negative 255 to be able to move in the opposite direction. So we're actually going to go ahead and set up a function that does what we want. And it's going to be pretty interesting, right? So here below the loop, I'm going to go ahead and, yeah, I think my arm is touching the camera. Man, the quality is so bad. I hope it's even legible. I'm glad I took pictures in the slides then. This is very hard to tell what's happening. But yeah, just for now, look at the screen, right? We're gonna develop a move function. For this, I'm gonna have an integer that is gonna tell me the motor type or which motor, and then another integer that's gonna tell me the speed. Motor speed. Something that you can do in C and C++ is to create a macro, right? We're going to create a macro because as you noticed, which motor is an integer. So technically I could only write move 1 and then the speed, or move 0 and then the speed, right? But that's not very intuitive. I want to be able to actually write motor A and motor B. What I'm going to do for that is I'm going to create a macro up here. And you do that by typing define. You type the macro, and then you type the value that it stands for. So motor A is going to stand for 0, and then motor B is That stands for 1. So later in the code, when I type motor A and 255, the compiler is going to replace this for the value in the macro, which is going to be 0. That's just something to help us make it more legible. So yeah, if which motor is the same as motor A, I want to do something. Else, if which motor is equal to motor B, I want to do something else, right? And then finally, if whatever the user put in here is neither of those, we just want to be able to print wrong input in move function. Move function. Actually, you don't want to capitalize. Oh, never mind. Move motor. Well, let's just do a move. That was fine. Move. Wrong input in the move function. So yeah, this is still very, I mean, we haven't done much here. We're calling this move function, and then if the motor is motor A, I want to do something. If it's motor B, I want to do something else. So if it's motor A, I'm going to actually write the speed of the motor. Now, I told you guys that you can set the speed of the motor from a range of 0 to 255. That's because you can actually write a sort of analog signal to communicate a range of values. Yeah, you have digital pins that do only 0 and 1, but then if you use this analog write function, then you're able to use a digital pin to give out a signal that kind of works like an analog signal. So I'm going to do enable A, is the pin that handles the speed for motor A. And I'm going to type here set speed motor A. And then the speed is going to be motor speed. Right? That's all fine and dandy. Then we have, actually, let's think about something. What if the user gives me a negative motor speed? What if the user wants to rotate the motor in the other direction? Then this is going to be wrong, because you cannot really write a negative number as an analog signal. So inside this if statement, we're actually going to have another if statement. If motor speed is greater than 0, that means that our motor is going forwards. Else, our motor is going backwards. So if our motor is going forwards, then we're going to rotate the input 1, input 2. Now, input 1 to high, and digital right. Input 2 to low. However, if the speed is negative, I want this to be flipped. Finally, I'm writing my analog write enable A, which is, this is going to handle the speed of the motor, right? But again, I am still in the same problem, right? What if the user gives me a negative number for the motor speed? This is not really possible. Well, there's in the Arduino math library, there's a function called absolute abs, and this is going to give us the absolute value of the motor speed. So even if it's a negative number, it's going to return a positive number. So I still haven't handled this function for what happens if we select motor B, but I don't mind. Let's just use motor A for now and test it. move motor A 255. Then I want to wait, and you wait using the delay function. I'm going to wait for 1 second. So it's going to be moving at full speed forwards for 1 second, and then we move it the other way. Motor. Oh, by the way, my macros were in full caps. It's very common to do your macros in full caps. Motor B, motor A, negative 255. We have another delay of 1000. So another thing, the delay function in the Arduino Ide, it works in milliseconds. So if you want to put 1 second, it's going to be 1000. If you want to do 5 seconds, it's going to be 5000. That's something to keep in mind. But now if I run this code, my motor A should rotate full speed forwards for 1 second, then backwards for another second, and do that indefinitely. Let's see if that's the case. I have my motor here. Oh, okay. I forgot a semicolon there. Now if I turn it on, it's hard to tell, but it is rotating one way and then the other. I'm going to make it more obvious by first we make it rotate forwards for 1 second. Then we're going to make it stop. Motor A 0 for another second. Then we're going to make it rotate the other direction. So let's see now. Let's wait for it to compile. It's rotates one way, the other, and it waits. And we could make it even more obvious by just having this also happen here. Yeah, I mean, you can imagine, right? By having a function like this, it's going to be very powerful because you can tell your motor to move one direction, the other, and the speed, and all that. So yeah, that's how you control the motors. Now, since we have very little time left, I'm just going to go ahead and very quickly develop the part for motor B here. If, yeah, that was not good. Just need this. If motor speed, okay, and that's going to be 3 and 4, 3 and 4, enable B, motor speed. Okay, so we develop our move function now. Now I want to go to the next part of our workshop. Well, yeah, right before we get there, there's something that I skipped. It's like batteries in general. I mean, this is very important. Any project that you're going to make with robotics or anything for really that is going to have an Arduino and you want it to be independent, right? You're going to need a battery. And the most common kinds that you're going to see, it's either alkaline, like the ones that we have here. 1 second. Alkaline, like the ones that we have here. There's also going to be LiPo batteries. It's very common in robotics. Very common in robotics. You also have lithium ion, which is what's used in Teslas. So that's pretty cool. But something to keep in mind with batteries is the arrangement that you put them in determines the properties that they're going to have. And this is very important. And we can see it down here. If you arrange them in parallel, the batteries are going to have the same voltage that they had in the beginning, but they're going to have more capacity. But if you arrange them in series, you're going to have the same capacity in the beginning, but the voltage of all the batteries adds up. So for this project, I'm using 4 batteries in series, right? These are alkaline batteries. And as you can see in the slide, this is at most 1.5 volts. But since they're in series, and I have them all together like this in series, this whole battery pack is actually outputting 6 volts. And that's what makes it possible for me to power this whole robot with these batteries. Now, I told you guys that these motors can take up to 12 volts. So you could make this robot a lot speedier. If you added either more batteries like this in series, you will need another 4, or you added like a LiPo battery that is rated for like 12 volts or anything like that. But yeah, that's something to keep in mind. Whenever you're building a project, you want to know what voltage you're going to need, and then you arrange your battery depending on that. So that's pretty cool. Now, when we did all of this, I feel like I went a long way, but if you guys have any questions, just let me know, and we're happy to answer them. However, if there's not many questions, I'm going to go through and actually teach you guys how to implement the line following. And in order to use the line following, we're going to use this sensor called an IR sensor module. But how does this IR sensor module work? Well, as you can see, you have 2 little LEDs there. They're not really LEDs. One of them is an IR transmitter, and the other one is an IR receiver. The way that this whole sensor works is it sends an IR signal, and it waits for that IR signal back with the IR receiver. If it receives the signal back, this pin right here is going to give out a 0. Sorry, my bad. This pin right here is going to give out a 1. However, if we don't receive the signal, then this pin right here is going to give a 0. Now, what does this have to do with our project? Right, at the end of the day, we have a line. A robot is a line follower. Like, of course, I mean, it's going to receive the signal back all the time. Like, what's the difference? Well, there's a cool property about IR waves, and it's that black surfaces absorb the IR signal. So if your IR sensor is shooting the IR through a black surface, like a black tape, it's actually going to straight up absorb the signal, and your sensor is going to be like, nothing happened, like no signal back. So we use that to our advantage to be able to build robots like this that follow lines. And they are very common, not only here, but also like in the Amazon facilities for their automated robots. They have a whole array of lines in the floor, and they just travel around like that. So yeah, it's pretty cool stuff. The way that I have it set up, and you guys can see it better in the picture, I have 2 of them in the bottom of my robot. And yeah, every one of them has 3 outputs. And you guys can see VCC, ground, and then out. Out is just a digital signal. So whenever the black line hits this, the out is going to change. So let's test it out. Okay. Actually, before we test it out, I need to introduce you guys to the idea of using breadboards. As you can imagine, this sensor has the need of 5 volts and ground, right? But our Arduino doesn't really have that many 5-volt pins. It just has 1 5-volt pin. How am I supposed to like share that 5-volt pin with my 2 sensors? Also, hi Ryan, Happy to see you here. How am I supposed to share that 5-volt pin to 2 sensors? You don't really do that. What you do is instead you connect the 5-volt line to a breadboard, and then all your sensors can connect to the breadboard. And that's how you can handle many sensors with just one 5-volt pin on the Arduino. And that's what's being done here. So yeah, I'll just do that quickly. If you guys have any questions on how to use breadboards, let me know. But yeah, I'll connect it real quick and then you guys can see. Okay, so and then 5 volts. Here to here. Yeah, just 1 second, guys. Train switch, purple, 5 volts. Transcribe. All right. So I went ahead and connected one of my sensors to 5 volts, ground, and then the output pin, I connected it to pin number 4. Keep that in mind. So here, I connected one of my sensors to 5 volts, ground, and then pin number 4 in there. You can see how it's coming from below the motor driver to pin number 4. So yeah, that's actually my sensor in the left, this one. So let's go ahead and start programming it. I will connect my Arduino back. And I'm gonna modify the code a little bit now. I don't want the loop to have any more functions. Yeah, and it's already not there. So I'm gonna have to create a new variable up here. This is gonna be sensors and sensor L for left. It's gonna be pin number 4. Now, anytime I want to use a pin, I need to define what am I using for, what I'm using it for, right? And sensor left is actually going to be an input pin because I want to read the signal that it gives me. And in the loop, I can actually use the serial monitor, serial.println, and I want to read. So digital read sensor L, sensor left. If I run this, I should get a reading from the digital monitor of that sensor. Let's see if it works. So it's giving me a bunch of zeros, right? And that's because the left sensor is not touching the line. But as soon as I go ahead here, look what happens. The output changes to 1. So what we know from this is that whenever my sensor left is giving me 1, I know that we are in the black line. I mean, we're already running out of time, but you guys can imagine. There's going to be 3 states, right, for this robot. The state where none of the sensors are in the black line, you were going to set both motors to go straight. When one of the sensors is in the black line, you want to set one motor to be faster than the other so that the robot can correct itself back, and the same way for the other. And that's how you would program the robot. We just don't have any more time, but I hope this was at least informative for you guys. And let me know if you guys have any more questions. It was definitely a lot, but I feel like it's pretty cool to program robots and stuff. And once you get over these basics, like then you can start building really cool ideas and projects. So yeah, guys, happy to see you all here. Thank you, man. And hope you guys have a good hackathon and good luck with your projects. See ya, guys.